Hi, everyone. Welcome to another segment in Chapter 6. And in this segment, we're going to look at the theory of production. We're not yet discussing costs, but we're going to discuss the theory of production and the decisions made in that approach. So as I mentioned, we're not really going to discuss costs yet. That's later in the chapter, costs of production. But we are going to talk about inputs and outputs. And we need to make a few decisions or a few definitions before we proceed too much further. Now, the short run is defined as a period in time with at least one factor of production fixed, one input or one resource is fixed. You've already made a decision on how much of that you're using. And that could be land, labor, capital, entrepreneurial effort. All those are our factors of production. So as an example, if you're a farmer, you've got a fixed amount of land. You basically have a field that you can farm. So that's a fixed factor of production, and that puts us in the short run. It's just a definition. Let's say maybe you have 2 tractors. That's another fixed factor of production that puts us in the short run. Or if I'm a pizza person, I've got a little pizza business and I have 3 pizza ovens. Well, that's a fixed factor of production. So is my store, for that matter. So once I've decided and purchased those factors of production, we call it the short run. In fact, every business is in the short run because they've all picked at least one factor of production that's fixed. So any business operating out there is operating in the short run. And we'll compare that to long run later on. Now, let's define total product or total production. That's the total output or the total quantity being produced in any production process. So it's the total output. It's what is being produced. I just want to be really clear that it's not inputs, it's not land, labor, capital, it's the total output or the quantity of the product. That's the total production. So I emphasize that so much because we go and use 2 other terms that include the word product. We look at this thing called marginal product and average product. Let's look at the average product first because it's a little bit easier to understand. The average product is the total output, so it's the total product divided by the quantity of inputs. Okay, so we're taking that to mean average product. To get an average, you always divide by something. And since it's the average production or the average product, we just take the total product and divide by the number of inputs required to produce that. So that one's not too bad and not too difficult to understand the intuition behind that. Now let's look at the marginal product. This is where we start getting into some of the key points in this theory of economics. It's the increase or the change in total product as a result of adding one more unit of labor. Okay, that's the critical point here. What is the change in total product as a result of adding one more unit of labor? That's what this triangle means. The triangle means change, C-H-G-E. It's the change in total output due to a change in adding the labor. That'll become critical later on when we start looking at costs as well. But right now we're just looking at the theory of production. So marginal product is the change in output we get due to adding one more unit of labor. So let's use this table to explain marginal product, average product, total product, and a few other key terms in economics, key concepts for this chapter. So first, just describe the table. We've got units of labor going from 0 to 8. So that's how many people that are working. The total product or the quantity produced goes from 0 to 4 to 16 and so on. The marginal product, remember, that's the change in output from adding one more unit of labor. That's 4, 12, 20, 24. And then the average product, remember, that's the total output divided by the total units of labor. So we've kind of got a feel for what this table looks like. We're going to be building a fence. I'm going to build a fence in my backyard. So when there's no labor, the total output is 0, and the marginal product, of course, is 0, and the average product, those 2 things are really undefined. But when we add 1 unit of labor, that's just me. I start building this fence. So I go to the lawn where I'm measuring it, and it's a very uneven lawn. I measure the board requirements. I run back to the garage. I cut the board. I run back to the fence where I'm going to put it, and I hold it in place and nail it on. So I managed to do 4 boards per hour. Not very productive, but the marginal product is the change in the output due to 1 more unit of labor. So there's the change in output, and the change in labor was 1 worker. Okay, so my marginal product is 4. Let's say I hire a buddy of mine. So a buddy of mine comes over, and now there's 2 of us working. Well, we find that we can put 16 boards up an hour, and because that buddy's sitting in the garage on the saw, I'm out by the yard measuring the board, yelling it to him, the measurement. He cuts it really quick and runs it out to me, and I hold it up, pound the board in, measure the other one, yell it to him, and he's back at the saw. So we find that with 2 people working, the marginal product is now 12. We went from 4 to 12 boards per hour, so the marginal product rose. Okay, this is interesting. So I hire 1 more person, another buddy comes over, and we notice between all of us, we can put up 36 boards an hour. And I think that's pretty darn good, but it's because we've got 1 guy permanently out in the garage sawing the boards. I'm permanently measuring and pounding them on my knees out on the lawn. And the 3rd guy we have is running in between, bringing the board to me, running back, picking up the other one, bringing it back to me. So we're getting more efficient. So we noticed that our marginal effort, marginal production from the 3rd person is 20. So that's increased. Thinking, well, this is a good thing. I'm going to hire 1 more person, and they come along, and they're now the runner, and they're helping hold the board in place. So I measure it, yell it to the guy doing the sawing. He cuts it up, hands it to the runner. The runner brings it back. There's a guy sitting there with me holding the board up. I tap 1 nail in and then finish the sawing while he goes and helps get the other board. So we've got now 60 boards per hour, and we realized that that marginal product of adding 1 more worker was 24. So we've really increased our incremental contribution by hiring another worker. So you may think, well, let's keep going. Let's hire a 5th worker. Okay, so we realized when we hired that 5th worker, we were able to do 75 boards an hour. But if you notice what happened, well, from 6 to 75, the marginal product is only 15. So right here, that extra output due to hiring 1 more person went down. So why? And the answer is, well, there was no more tasks to split up. We had someone doing the sawing, we had someone doing the running, we had someone holding the board while I pounded it back in, and then they measured the next board and yelled it back. The guy sawed, the runner brought it to us, he held the board while I pounded it, measured the next board. So there was really no extra definable task for somebody. Sure, they came in and helped running a little bit, and they helped sawing a little bit to give the person on the saw a break, but it did increase our overall boards per hour, but there was a decline in the marginal product with that 5th worker. So let's say, okay, well, let's add a 6th worker. And again, we increase our total output from 75 to 84 per hour, but that's only 9 boards extra per hour. Marginal product fell even further for the same reason. That person was trying to help. Maybe they subbed me off on the hammer for a little while I went for a sip of water, and we could keep production going. But the incremental increase isn't as strong. We do the same thing with the 7th worker and bring someone else on, and we notice there's absolutely no change in output per hour. That person is subbing in and helping where they can, but they don't have a separate definable task. So the marginal increase is 0. But notice we're putting up 84 boards an hour still. It's not falling off until we hire worker number 8. And worker number 8 comes along, and they are a joker. They're a card. They yuck it up. They laugh. They entertain everybody. They kind of get in the way. Sure, we're having fun, but we've actually noticed that our boards per hour has declined by 12, just because we brought in this last person who's not only not contributing much more to the production, but actually taking away from the overall production because he's providing so much entertainment that people are slowing down in their work. They're watching him clown around, making a real fun afternoon, but not nearly as productive as without him. So you can see marginal product rose to a particular point right there, 4, 12, 20, 24, and then started falling off and becoming negative after that. That's happening for two reasons. We'll look at those a little bit later, but I want to just point them out now. In the next slides, you'll see that marginal product is rising due to the division of labor, due to the fact that we're splitting up the tasks into definable activities. And then past that, we see the marginal productivity falling. That's called the law of diminishing returns. So as we hire more and more people past this point, the marginal increase in production from hiring them starts falling off. Notice that the total production keeps rising for a while before it starts falling off. Well, the same thing can happen or does happen for average product. We see as we hire more and more units of labor way over here, the average product rises to a point and then it starts falling from there. And that point is also called, that point is called the point of diminishing returns. But we see that division of labor has increased average product, and then the law of diminishing returns kicks in and that decreases average product. So it's the same concept, the same economic concept, division of labor, and then law of diminishing returns that causes both marginal product and average product to rise to a peak and then to fall off from there. That peak is called the point of diminishing returns. So on this next slide, we actually define these things. And it was a good thing we talked about them on the previous slide at a more intuitive level because the definitions are a bit wordy. The law of diminishing returns. Well, it says as more of a variable input is added to a fixed input in the production process, the resulting increase in output will at some point begin to diminish. Okay. You have to understand what this is and what it means, even if you can't memorize the definition. You have to have a good feel for what it is because you will have to explain it. So the more of a variable input, well, that's the labor, my buddies, the workers coming over. If the more of that that's added to a fixed input, well, that's the one hammer, the one tape measure, the one saw in the production process, the resulting increase in output, in other words, how many more boards per hour can we add by hiring one more worker? At some point, that increase in output begins to diminish. That's at the point of diminishing returns. So the marginal product rises at first because of this division of labor, but at some point it falls because of the law of diminishing returns. The division of labor, as we said, is dividing the production process into a series of specialized tasks. So each worker has a specialized task, and that's when they become specialized like that, that's what increases the marginal productivity of the whole production process. And then we hit the law of diminishing returns. So I just wanted to pause that for a second and let you think about it. All production processes are like this. If they've got some fixed input, and they all do, then the type of operation it is will show increasing marginal product due to the division of labor. And then at some point it will show the law of diminishing returns kicking in, where you've just got too much variable input being added to the fixed input. And it's probably time to expand your fixed inputs if you want to keep moving along in that positive direction. So what are the benefits of the division of labor? Because this is such a significant thing for us. And there's several. At first, it just gives us the ability to fit the best person to the right job. I mean, who saws the best? Who hammers the best? I love hammering, so maybe I'm best to be put on the hammer, but my other buddy's really good on the saw, very accurate, specific, and we should put him on the saw. Also, you get increased dexterity, as anyone would know, when one worker focuses on a single operation. So if someone starts pounding the hammer for a while, at first they're going to be really slow and take 5 or 6 taps to get the nail in. Maybe they hit their thumb a few times and that slows them down quite a bit. But after a while, they just set the nail, pound it in. Set the nail, pound it in. They become a lot better, increased dexterity, when they focus on a single operation rather than having to do many. The other time is time savings from not having to change tools. So I don't have to switch from the hammer to the tape measure to the saw, because that takes time. So time savings is a benefit. And another way to gain time savings is the fact that I don't have to move from where I'm pounding the boards in at the fence and run all the way to the garage where the saw is all set up and come back again. That wastes time. So there's time savings gained by not having to move there. And this last one is more of a general point. When you have specialization or division of labor, that helps with machine specialization. And that is the same idea, only it's a machine that's developed around specific, discrete tasks that the company has to do or the production process has to do. And that was the key to the Industrial Revolution in the world. Basically, like think of a car assembly plant. People are working between steps of the automated plant. So you get certain steps that workers have to do that can't be automated, but a lot of it can be automated, and you get the workers to work in between on those steps. That's machine specialization. But those first 4 points, the ability to fit the best person, increased dexterity, and 2 types of time savings, those are really critical to the benefits of the division of labor. So now we're going to graph the table that we looked at a couple of slides ago. All we're doing is graphing the numbers to try and make a little bit more sense of all this. So first, read the definition there. It's explaining that average product will rise if marginal product is above it. That's kind of like saying, does everyone know their average in this course so far? And if your next mark, your marginal mark, is above it, then it pulls that average up. And if your next marginal mark is below your average, then it pulls the average down. So that's pretty intuitive. Let's take a look at what we mean by that. Here is our average or our marginal product rising to a point that we had on the table just after the 4th worker. So that means our average product is rising, the curve below it. Sure. And then when we hire our 5th worker, the marginal product has fallen off and it's just equal to the average product. The blue line equals the green line here. And then after that, the marginal contribution for the extra worker, the 6th worker, is below what the average is. So the average starts falling down. So I'll just label this as marginal product, and the other one is the average product. So those two make some sense. Along the horizontal axis, the bottom axis here, it's just the number of workers. And if you went back and looked at the table, you'd see that. So we define a few points around this. This is the point of diminishing returns, right here, the highest point of the marginal product. And that's where we had the 4th person, and we don't know it's the point of diminishing returns until we hire the 5th person. And we see that the marginal contribution starts falling. Not as many specific separate division of labor tasks are available. So then we define one other piece that's really critical. It's the top of the average product, and we call that the point of maximum productivity. So that means on average, in my production process, this is my highest average output. Maximum average product is maximum productivity, another key point that we want to know. So then if we go up top, we're just graphing total output. Remember, it wasn't until we hit 7 and brought the 8th person on did total output actually start falling, because we brought in the comedian that got in everybody's way and took their focus away from working. So, but we do see a rising total product, and then we hit this kind of transition. You see where the curve kind of is speedily sloping up, 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 and then it kind of turns and starts sloping less. That's the point of diminishing returns as indicated on the total product curve. And we keep going, and we find that at this point we're at our maximum total product per hour. After that, it starts falling off when we hire the comedian. That maximum total product also coincides with where our marginal product was 0. If you go back to the slides, you'll see that the incremental contribution to output rose and rose. Finally, it hit 0, and that was the point of our maximum total product per hour. After that, the marginal increase from hiring that next person brought the total output per hour down, as indicated by this line coming off. So this is the point of maximum total product. On this slide, we see 3 key points. The point of diminishing returns. Before that, the division of labor is helping us. Then we hit the point of diminishing returns, and after that, it's the law of diminishing returns that takes over. We see that on the total product and the average product, but it's probably most clear on the marginal product curve. So make sure you know where these 3 points are and how they relate to those curves that we have up there on the graph. So that's all we have on the theory of production here. It's a nice tight segment. Some of the new concepts are a little tricky, like marginal product and average product, but if you go over it a few times, I'm sure it'll sink in. I could also suggest another website called the Economics Classroom, or the Econ Classroom is a better way to search it up. It's Welker Economics. And if you look at the theory of the firm, you'll see a nice example of this. It's a toy truck factory. They're producing toy trucks, and they're adding incrementally more and more workers to a fixed amount of tools that they have. So it's also a nice different way to see these exact same concepts. So I'd advise you to go there as well. The Econ Classroom, Welker is the gentleman that does it, and it's the theory of the firm and a toy truck factory. But that's all for this segment. We're going to move on to short run costs, variable and fixed costs in our next segment, and we'll see you when we get there.